This video has been provided by Japan Space Systems and serves as an introduction to the Space Solar Power System, or SSPS, related demonstration experiments that were conducted in 2024. With the support of the Ministry of Economy, Trade, and Industry of Japan, Japan Space Systems is developing technology to make SSPS a reality. SSPS is a new type of power plant in which solar panels are placed in geostationary orbits, generating electricity from solar light. It then sends this power to the system on Earth via microwaves or laser beam, supplying electricity to the power grid. By generating electricity in space, we are able to generate it and send power to systems on Earth without it being affected by current weather conditions or hours of daylight. SSPS consists of a space solar power satellite in space and a power receiving system installed on Earth. We at Japan Space Systems have utilized the tethered SSPS concept with a panel system arranged in a flat 2.5 square kilometer area. This concept uses the Power Generation and Transmission Panel, or PGTP, as key technology, which combines solar cells, the electricity to electrical waves converter, and the antenna element to send the electrical waves to Earth. Let's take a closer look. The tethered SSPS transmission system is a combination of several satellites, each of which includes panels composed of PGTP units arranged in approximately 100 meter squares, a satellite bus section, and multiple tethers connecting the panel and bus. Next, let's take a look at the ground system side. Microwaves from space are received by the ground system antennas, then converted into electricity. The ground system then converts the electricity from DC to AC and supplies electricity to the terrestrial power grid. Japan Space Systems aims to be able to supply approximately 1 gigawatt of electricity through this combination of floating power transmission system and the power receiving system on Earth. This amount is equal to around 10% of Tokyo's electricity consumption. The demonstration experiment we will be introducing today is a concept evaluation test for the tethered SSPS. Our purpose for this demonstration was to visualize the same situation as when the SSPS is actually made a reality, using an SSPS concept model, have it reach a wider audience, and through this video, let people know that SSPS is not science fiction, but familiar technology that is close to becoming a reality. For these reasons, the power transmission and receiving components used in the concept model have been made to be technologically identical to the components used for tethered SSPS. This is a general overview of the test equipment. For transmission equipment, we have created a full-scale PGTP that is used by the tethered SSPS for the same purpose. As for receiving equipment, we have arranged them to circle around devices which are technologically identical to the SSPS ground system. Both the transmission and receiving equipment were placed in a line with respect to the Sun. In this demonstration experiment, we have replicated the following processes that are also used by SSPS: generate electricity from solar energy, convert generated electricity into microwaves, transmit microwaves from the transmitting antenna, receive the transmitted microwaves with the receiving antenna, convert received microwaves into electricity, and use the converted electricity to power the model train and move it. Now, let's take a look at the actual demonstration experiment. The screen configuration is as follows: the panoramic view of the test equipment, an image of the positional relationship between the Sun and the test equipment, an image of the PGTP, an infrared image of the PGTP with the same angle of view, the model train to indicate when electricity has been received, the schematic diagram of this demonstration test, along with an animation to show how far energy has been transmitted, the status of the evaluation in text. The time elapsed since the start of the test video is also displayed on the bottom right side of the screen. We will now start the test. The test has just begun. The solar cells in the PGTP have already started generating electricity from solar light, but has not started converting electricity to radio waves yet. The PGTP has now started wirelessly transmitting power. Meanwhile, the power receiving equipment has received the microwaves and is checking the power level. The power receiving equipment and the model train have been connected, and the train has started to move. As you can see, electricity was generated only by solar light, converted into microwaves, transmitted wirelessly, and the received microwaves were converted into electricity to power and move the train, under the same conditions as when SSPS is made into reality. These operations were carried out without consuming any fuel other than solar light, and without any emissions such as CO2 or other waste. Here, the wireless power transmission has been stopped, and so has the model train. In this experiment, we conducted a demonstration of the SSPS concept model. We hope this will help you further understand SSPS. Japan Space Systems will undertake the following two initiatives in the coming years. First is WPT flight demonstration. We are preparing to attach the power transmission equipment to aircraft and conduct wireless power transmission experiments between the flying aircraft and the ground. We plan to implement this experiment in winter of 2024. Second is to demonstrate microwave power transmission from the LEO to Earth. For further development of long-range WPT technology, we are planning to launch an experimental satellite named Ohisama by 2025 and conduct experiments regarding electricity transmittance between LEO and Earth. Japan Space Systems will continue to work to make the space solar power systems a reality.